and welcome to the Space Policy edition of Planetary Radio. I'm Casey Dreier, the Chief of Space Policy here at the Planetary Society, welcoming you to yet another episode that explores the policies and processes behind space exploration. I've been trying not to get too much into the day-to-day activities of politics and policies in this show lately. I've been wanting the episodes to more stand on their own and be relevant for years to come, thinking about big ideas and big thoughts in space. But it's worth stopping for a minute at the end of this year, in December of 2025, to reflect on what has happened, what we've done, and to really discuss and kind of consider why we care so much about space science in the first place. Earlier this year, we were confronted with probably the worst budget ever proposed for NASA, certainly for NASA science. We saw cuts upwards of 25% for the agency overall, but 50% for the science activities. Things like the robotic missions to Pluto and Jupiter would be terminated in mid-flight. Earth science, heliophysics, almost every space telescope would have been turned off, except for the Hubble and James Webb. And basically, the pipeline of future missions would dry to a trickle. Research funding across the nation would be eviscerated, and many other long-term and consequential impacts would have occurred from this, and still may occur. In response, here at the Planetary Society at least, we tore up whatever ideas we had for that year and started anew with the Save NASA Science campaign. This was a sophisticated and very ambitious effort to provide a consistent framing, media outreach, political outreach, and organizational engagement with you, our listeners and members of the Planetary Society, to push back in a way that would stop these cuts in their tracks. And that is actually largely what has happened. As I record this, we have budgets from both the House and the Senate in the U.S. Congress functionally rejecting the full extent of these cuts. The exact details are a bit different between each one, but the big point is that no one is embracing this idea. We have a number of missions that were proposed to be canceled now getting confirmations. For example, OSIRIS-APEX going to the Apophis asteroid, and other missions that are functionally being told to continue planning for operation and no longer for termination. We are created, I think, a broad understanding about the importance of NASA science and the importance of this role as a unique capability of the space program. And that's pretty incredible. I want to encourage you to go to planetary.org and check out our 2025 impact report for a lot more of the details and numbers about what we have done this year for advocacy. But I'll just say again, this is like nothing we have ever done before, and we could not have done it without you, listeners and members in particular of the Planetary Society, who provided us the financial resources to mount this sophisticated year-round and truly unprecedented campaign, including a second day of action that brought together nearly 300 individuals from around the country in arguably, I think, the largest single in-person day of action congressional advocacy event ever in NASA history. Again, that's at planetary.org. Search for the impact reports. And for those of you who aren't members, please consider joining us or donating to our advocacy program, because I strongly believe, hopefully if you're listening to this, that we are delivering results, and we as the Planetary Society have been nimble, profoundly reactive, and functional and fast. That we as the Planetary Society have mounted a highly sophisticated and effective campaign in a way that no other organization was truly able to do, given our independence, our lack of government contracts, and our broad focus on science, space science in general, and not any particular interest group. Planetary.org/join, if you're not a member, that is something to consider for any holiday season, but any season, an investment, that this is something that is an ongoing effort. These cuts can always be proposed again. We intend to not let these happen ever. We will never stop, as long as we have the resources to enable us to fight for this. Dr. J.S. Johnson-Schwartz, who was my guest, I should say, this is an interview from a few years ago, was very much on my mind throughout all of this. Their book, The Value of Science in Space Exploration, is among the top most influential books I have ever read that has helped me form my ideas and thoughts and framing for the fundamental reasons about why we explore space, and particularly why we explore space science. What I love about this work is that they tackle a question sitting underneath everything we've been doing. That's even more than the real and acceptable reasons, but the fundamental obligation question. Do we have an obligation, a moral obligation to explore space? And what are we obligated to do? Their conclusion, which may not be surprising to you given the themes of this show and the Planetary Society, is that science itself is that fundamental moral obligation. It's not enough that we just are able to do it. If we are able, we have an obligation, a commitment to ourselves to learn more about the cosmos in which we inhabit. I think that was a very novel philosophical framing. Ethics is a big part of space, and it's a very interesting part of space exploration. But again, the framing it as a concept of obligation, that's interesting. The reasons we'll get to in this discussion, which we had back in 2020. But the idea is that knowledge itself is an intrinsic value. Even if knowledge gave us nothing, no spinoffs, no economic benefit, nothing beyond that, it would still have a fundamental value to us. We talk about in the range of options that we can do in space, which include valuable and useful things like commercialization and settlement in the long run. Science itself still presents an immediate obligation rather than a long-term one. And so that provides prioritization in terms of how we focus our efforts in space exploration. And then we talk more about how ethics can influence how we make the decisions together as we go into space. And the value, I'd say, and fundamentally the importance of public space agencies with a responsibility to represent public interest in this whole endeavor. Dr. J.S. Johnson-Schwartz wrote this book. I highly recommend you read it. Certainly was interesting to me, as you can tell. But again, this interview and this book are worth reflecting on at this point in time as we face what I consider the most successful year in Planetary Society's advocacy program, but one that we cannot take for granted or rest on our laurels. This could come again, and we need to keep this up. So to every one of you who have donated, advocated, written Congress, called Congress, done anything, shared, retweeted, or reshared any type of post about this depended on you, and you really stood up for this. So I thank you, and I'm grateful for this organization and the membership that we have that enables this to happen. And now my 2020 conversation with Dr. J.S. Johnson-Schwartz on the value of science in space exploration.
Thank you so much for joining us here at the Space Policy Edition.
Oh, thank you so much for having me.
This is a big topic, but just to get us grounded with the audience, and then we'll go to explore more detailed aspects of this. Do you believe that humans have a moral obligation to explore space?
I do, and I think that obligation can come from many places, and something that I actively think about in my work relates to, where does that obligation come from and what sort of specific space activities does it support?
Space exploration is a big concept. I don't have a grounding in formal philosophical training, so you can help me if we're stumbling over some technical definitions here. But when we talk about moral obligation as a philosopher, what do you mean by that, maybe to even go a step further? What does that impel us to do as an individual and as a society?
Yeah, so the classic thought relating to this would say something like, if you're obligated to do something, it's right to do and wrong not to do. If something's merely just permissible, that means you don't have to do it, but it's not wrong if you do. And then we get into the other side of things where activities could be morally impermissible, which would sort of always be wrong to do. So when we talk about space exploration being a moral obligation, we're meaning that there is some moral failure on our part if we don't take action to attempt to satisfy that obligation.
Reading your work, and I'll just, again, plug your book right from the beginning here, the new book, The Value of Science in Space Exploration, which is available on Amazon. Something that struck me was that the moral case that you make for space exploration is actually not the kind of intuitive one that I had, and I think a lot of other people have, which is related to basically a very human-centric attitude of self-preservation and a host of other kind of outlined motivations for exploration, romanticism, frontierism, and so forth. From your kind of perspective, what do you argue? What aspect of space exploration is the moral obligation, and why does that rise to the top compared to some of these other more common intuitive concepts related to space exploration?
Yeah, good. Big question, right? So the approach I take, what I identify as what I think is the most compelling reason to engage in space exploration relates to scientific study and the knowledge and understanding of the universe, our solar system, and ourselves, really, that we could derive from the exploration of space. And something worth saying there is that, space exploration always tends to provide us with, new situations and new environments, which have the opportunity to bring up experiences we've never encountered before. And there's always this fruitful way of trying to implement that into our existing understanding of things. And so space really has a lot of opportunity to present anomalies that cause us to rethink some of our basic principles. And it's, colleagues of mine will liken this to when Einstein is asking these, really obscure questions about what would it seem like if I was sitting on a ray of light. And an ultimate product of that is we have laser eye surgery. Now, if you're sitting in the late 1900s asking yourself, how can I make surgery? Late 1800s, asking, how can I make surgery better? You're never really going to happen upon the laser as an idea. So it's this notion that through improvements in science at a basic level, we lead to progress in other areas, even if we can't always predict what that progress is. And so I think that provides the strongest basis for justifying space exploration, right now in terms of the things that we can do in the near future. But you're right to say that the rhetoric surrounding space exploration brings up a whole host of other sort of competing claims about ensuring long-term human survival, and for that we need space settlements, making sure we don't run out of necessary vital resources, and so we need to start exploiting resources from the asteroids, from the moon, and elsewhere. It's not as though I don't agree that there's some benefit, there's some good that could be derived from those activities. But when I look at the landscape of space exploration, and as you say, there's a lot there, one thing that a philosopher notices is that there are competing objectives and competing principles that couldn't all be satisfied together at the same time or in a certain order. And so when I talk about obligations associated with space exploration, I sort of want to ask, what is it that we can most effectively do right now? And that's going to enable the sort of strongest obligation to conduct that particular activity. And when I look at, say, space science versus space mining versus space settlement, it seems to me that it's the science that really stands to benefit us the most.
I was fascinated to read that phrased in that argument. And to be clear, I guess we're talking about the near future being, I think, something like the next 200 years, roughly, right? Assuming no fundamental, transformative, physics-breaking new technologies, right? If I remember correctly, roughly from your book.
Yeah, that's a sort of beyond that, I'm not going to be so confident about, what technical possibilities there are. Something could always come up tomorrow that completely changes things. But, reflecting on the direction technology has gone, how long it's taken to get where we're at, I don't see burgeoning human societies in space until at least a century from now, if not longer.
And so given that constraint, this is what was so interesting to me, because going back to the in the history of spaceflight, at the very earliest days, there was this debate about what type of space program did we want. I'd say crassly characterized as the kind of Eisenhower complex of the science-focused, modest, stepwise approach that has clear direction from clear returns in terms of science as a value in and of itself. And then versus more of the Kennedy-style crash program, political statement, big spending on human spaceflight, which is ultimately what it became. But the one consistent focus, even though a human spaceflight in the US at least has waxed and waned over the years, science has been relatively consistent as a core motivation. So reading this in some ways, it felt like I was seeing some sort of a rigorous grounding in what we already observe of this, the role of science within space exploration. And in that sense, do you think that the role of philosophy here, the role that you're bringing, your perspective, or how do you hope it plays into these larger policy debates,
Yeah, good. Yeah, I think you picked up on something important there that, I'm not necessarily offering brand new argument. I'm trying to really clean up some of the rhetoric and arguments that are out there. When I first started thinking professionally about space, which for me would have been while I was working on my PhD in philosophy of mathematics of all topics, the things I was reading as a sort of analytic philosopher just seemed very tenuous to me, that the arguments weren't fleshed out very well, that so much was left to appeals to emotion, which left me wondering, what can I actually prove, or what is there genuinely evidence for when it comes to these arguments that are made about why space exploration is so important? Because it just seems like, there are these talking points that people throw out again and again and again and keep wondering, why aren't more people interested in space? Why aren't we seeing an increase in the budget? I mean, there's a practical end to this, which is, a more rigorous exploration of what kind of advocacy could really work to secure funding increases. And, I'm not a sociologist, so I'm not going to be the best one to ask about success or failure in terms of that. But, this question about getting back to fundamentals. And so, as I was exploring the different rationales out there, science really did seem to me to be a significant issue. But that, again, when I was trying to find examples of people that were arguing why science is important, you ended up with, a very similar kind of discussion that, it's this noble endeavor, it's inspirational, and so on and so forth. You never kind of get anything there that you can say, yes, that's a clearly true, uncontroversially true premise upon which to base an argument. So a lot of the claims about the sort of value of scientific knowledge and understanding tended to be assumed rather than demonstrated. And so I felt it really important. If I think that the science is the main thing to focus on right now, and focusing on science doesn't mean casting out every other activity, it means something more like, when there's a conflict between the two things, pick the one over the other. But in situations where there's no such conflict, we don't necessarily have to worry. But nevertheless, can I provide a very substantial basis for claims about why space science is important? I've done my best, as it were, in a couple chapters in the book to try to establish both that scientific knowledge and understanding are sort of valuable in themselves, what a lot of philosophers would call intrinsically valuable, but also in a more pragmatic or practical sense that there are good consequences that accrue to those societies that engage in scientific exploration, and that space science is a particularly fruitful avenue for that.
Yeah, I was particularly struck by your argument along those lines of the means of scientific exploration, that in terms of kind of framing it within our classic smaller case L liberal Western democratic societies, increasing the means of access to participate in that is argument as a net good in and of itself through the process of exploration and scientific inquiry. And I thought that was kind of a fascinating, like you tie these arguments for science and space science to these really broad societal benefits in a way that I found quite compelling. And I have to admit, I'm quite susceptible to these arguments. I'd like them to be true.
I am
but
too.
At the same, right? But maybe just expand on that a little bit. Like, how does science, particularly space science, as you kind of phrased it in your book, how does it become, in a sense, this instrumental good to society beyond just being kind of good for the more abstract, it's good to understand the cosmos better?
Anytime you're attempting to come to understand something you don't previously understand, that's always going to produce, not only an increase in knowledge, but it tends to come, what tends to come along with that are other sort of unanticipated consequences. And this is kind of sounding like the spin-off justification that you hear, that, there's all these technologies that get developed out of the space program. And of course, there's a lot of public confusion about what things are actually spin-offs and what things aren't. Tang, Teflon, Velcro were not spin-offs from the Apollo program. However, they were, used quite visibly during it. It's not just the idea that we're sure to get, new technologies, although that has to do with it. It's that, again, in attempting to come to understand the unknown, and space is unique in that it provides a lot of unknowns. It's, a very unexplored environment. The deep sea would be the sort of next closest thing when it comes to how little we know about a place, and so how much we can stand to learn from examining it. when you're trying to incorporate, this new planetary environment, there's something unique about its atmosphere. There's something unique about the geological processes going on there. What you can tend to find is that your theoretical ideas in that discipline might need some revision. That, you've set things up in a way where you can make really good predictions about terrestrial cases, but now when you're on Mars or Titan or something, the systems are behaving differently. So you've got to revise your principles. And when you revise your principles, you typically end up with a sort of better theory overall. This is almost kind of like a Kuhnian scientific revolution on a smaller scale. Now that you've got better principles, when you start employing them in every other place where scientific ideas get used, things can get better. And that's how we get things like technology development and spinoffs and such. So it's really trying to build up, what is the scientific case, as it were, what's that process by which these, societal benefits arise.
Yeah, I kept thinking about the term. It's like applying a stress test to any theory. Apply it to some weird edge case. It's kind of rephrasing. I kept thinking in my head as I was reading that same argument. We're witnessing that actually happen right now with the cosmological constant, where we have two separate methods returning two separate non-overlapping answers. Something about our understanding is incorrect, and that model has to be improved to take into account these two sets of data coming in, whether you're looking at one type of variable star or one type of background radiation versus some type of type 1a supernova distance measure. And we're watching that happen now, where they don't know the answer, and that's where the fruitful investigation is happening. I've always felt this as like space is literally a way to force us to look up and out, right? Where we have to take in new information because there's so much new stuff out there. By consequence of it's just size. Seeing it, and I appreciated, though I have to say I struggled with it because I'm not a philosopher. You have a pretty rigorous philosophical argument that you make, again, for the intrinsic value of knowledge for the sake of knowledge. Correct me if I'm wrong here. That you're trying to establish these kind of ethical or moral obligations beyond cultural conditions. Is that an accurate way of stating it?
Close enough, I think. It is ultimately a kind of cultural argument because it's one that sits in the sort of scientific worldview, and not every culture is going to be, a participant in that worldview. But, when I look and see humans doing the things that they enjoy to do, and I see a lot of folks are passionate about science without seemingly economic motivation for doing so. There's just this sort of, passion for knowledge and understanding. I want to say that that's an aspect of human behavior that cries out for explanation. And what I'm kind of offering by way of some formal debates in this area of philosophy known as epistemology, the study of knowledge, what knowledge is, what are the conditions for having it. There's been a conversation in that of those scholars about what the value of knowledge is and how that might be tied into a definition of knowledge. We don't need to get into any of that. But the thought is, there's a lot of people that behave as though this knowledge is worth acquiring for its own sake. Just as a lot of people behave as though, artworks are valuable, or the experiences of them are worth having for their own sakes and things. And I tend to think, well, that's how we normally attribute this, intrinsic value to most things that we say that have it. And so, by parity of reasoning, it seems like we can say the same things about knowledge and understanding. And so, in the book, I'll try to deal a little bit with, is there some subjectivity creeping in here? I mean, what are the standards by which we make these judgments? I have some responses there, but the basic outline of the argument is, it seems like this is a value that folks already have. And so it's part of the data that we need to include when we're devising our theory of intrinsic value.
Given all this, in a sense, why do you think the concept of science as the moral obligation or the prime obligation of spaceflight right now, why do you think that tends to fall by the wayside, at least within the community of space advocates, people who are really into space already, right? Like, you don't have to convince them that it's a cool thing to do. Where does that breakdown occur? And maybe even before we address that, you can highlight just a couple of the common advocate tools that you kind of try to dismantle a little bit in terms of argument for space exploration.
Yeah, so I think this is attaching a lot to folks that are justifying space exploration because they think, we need a backup planet to save the species, or that we need space resources to sort of solve all of our sort of terrestrial resource depletion problems. And I think that in some areas, the apparent falling by the wayside of space science, or at least its diminished attention compared to other spaceflight activities lately. I mean, there's that sort of Elon Musk effect, right? That there's sort of focus on commercial space exploration that's coming, especially from governments these days, wanting to, minimize federal funding put into space by trying to get more out of the private sector. And so we see, we've got some pretty charismatic leaders of some of these space companies that really do a good job with PR, getting their message out there. And so I think part of this just comes from the fact that the message that people are hearing more often has to do with, Elon Musk's plans to make Mars a backup planet for humanity than, your little science missions that might take place that get in the news for, maybe a few minutes and don't tend to stay there. So there is a sort of information effect in terms of just, what the media puts out affects, what people think is actually happening. So that, I think, plays a pretty big role. So what do you say to someone who comes into space because they heard somebody talk about, the great need for a settlement on Mars to save the species, or because they've heard that, asteroids will solve all of our energy or resource crises or something like this?
Why do you think those other arguments are so persistent, given that science, you've made a very, I think, strong from first principles a priori argument for the value of science, or the priority of science as a driving force for space exploration. Where or why and how do these myths that you, as you described them, kind of continue to persist given that?
Yeah, so I think this relates to the sort of messaging that was especially given, early on in the space program, the rhetoric that started to surround Apollo, and people's fond memories of that, because Apollo is, really remembered as this great success. We got to the moon, and we haven't done that since. And so there must have been something about what we did back then that really works, that we just need to recapture now. And of course, speaking about space as this place where it's a frontier to be conquered, talking about explorers in very dramatic ways, really harkens back to these grand moments of space exploration. And I think there's a perception out there that if you can make somebody feel that way, and you can make enough people feel that way, that's going to lead to changes in policies and funding levels. And the issue with that relates to, well, if you go back and look at what the public opinion data was saying in the Apollo era, I mean, most people, the majority of people, thought that too much money was being spent on Apollo. And it was only after the program succeeded that people started to have slightly different opinions of this. Roger Launius has talked about this a lot in his research on the history of Apollo. There's been that die that was cast sometime in the 60s or 70s, and it's just been using that again and again without much thought to what might be a different and possibly more effective way to rally additional public opinion in favor of space. So I think it just does, it's sort of a tradition that people fall into without necessarily thinking too much about, is this tradition one that is pointing to genuinely effective, well-grounded with evidence reasons or not? So when I look at it, I want to ask, all right, well, if these things are true, it would be nice to be able to support that with evidence, because as a philosopher, I try to want to avoid promulgating ideas and beliefs that I don't think I can justify.
As a space advocate, as a professional space advocate, right, I admit that I am guilty of some of these stories promulgation that you talk about. And as you were talking about this, I was thinking, there's the context in which sometimes you're making these arguments. And I am thinking more in this case of, like, if you're in a political office or a congressional office, you don't have a lot of time to build a careful case. It's like a shortcut in some ways that some of these stories, for example, the frontier myth, let's say, or the great exploration concepts, these very romantic notions, they fit into a pre-existing, at least in this country, I'd say cultural framework. Mm-hmm. And so you can communicate so much very quickly by tapping into this infrastructure, and it's this cultural infrastructure, and you slot your desire within that. It's harder to step back and say, to kind of start from step one and try to build a careful argument merely because of the context in which you share that. So I wonder if that's part of this, and that people are trying to compete for attention. They're trying to compete with a small amount of time. So they kind of default to these familiar stories in which to spin this narrative. And I think, you see that so much in what von Braun understood and Willy Ley back in the early days of space exploration, trying to understand, in a sense, the cultural id of the United States, of this frontier explorer community. Mm-hmm. And so I wonder if that's how this persists, regardless of its accuracy.
So I think it would be interesting to see some, dedicated research from a sociologist or a psychologist on this issue to identify, to what extent is this kind of rhetoric effective when it comes to space exploration in particular. Because I'm willing to admit that even though a lot of these claims might be sort of evidentially deficient, rhetoric still moves people, right? People can be persuaded for all kinds of, less than great reasons. Even if they're motivated to do something good, sometimes it's motivated out of hatred or fear or something, right? I'm not necessarily the best person to ask about how do we tell whether this stuff is effective at shifting public opinion. I'm a bit more interested in the question as to whether is the moral argument a good one. Now, there's a but here. And that's that the way we frame space exploration also has an impact on what we choose to do in space and how much we think we have to consider what we're doing. And so something that the historians that have opined about this frontier metaphor are going to remind us of is that the frontier, the American expansion into the West, there were a lot of really bad lessons that were learned there in terms of how the people that were expanding fared, how the folks that were already there that got displaced fared. There's a lot of senses in which the lessons we ought to learn from that metaphor are unwelcome rather than welcome. And so if we stick to this sort of dominant American sort of mythos here in terms of how we talk about space and think that that's how we're going to be conducting things like space resource exploitation and space settlement, I think that can cause us to think that we don't have to ask further questions about what we're up to, why we need to do it. And that could lead to problems down the line in terms of, space resources would be a good example of this. Something that I lay out in the book is that when you look at the research about asteroid resources, and in particular near-Earth asteroid resources, you've got to factor for all of these practical considerations like, on what orbit is the asteroid? How long is it going to take to rendezvous and return material back? What are the launch windows? Because, going to an asteroid is kind of like an interplanetary mission where you've got to time things properly. So even though the total resources available might be pretty significant from all the NEAs, the ones you can get to over the next year with a reasonable amount of fuel are very, very small in number. If you think about space as this vast open frontier ripe for human conquest, well, you're only really getting this little rubble pile for the next year. That's not a vast frontier. That's a tiny little thing that you're going to use up really quickly. You should maybe think about that a little bit more in terms of what's the best thing I can do with the materials from this, 100-meter diameter S-type asteroid that I've recovered. I think the metaphors that a lot of people have put a certain kind of complacency in their thinking about why is space important, what should we be doing up there, when we're at a point now where it's really, really important to be asking these questions because some of this major activity looks like it might start to happen in the next few decades. And, this is our chance to prove that we have learned from the past. And I'd love to be able to say 50 years from now that we did so, but it seems to me that the current momentum is one that says, what past? Clearly, this is just the right thing to do now, and we don't need to think any further about how to do it.
We'll be right back with the rest of our Space Policy edition of Planetary Radio after this short break.
Greetings, Bill Nye here, CEO of the Planetary Society. We are a community of people dedicated to the scientific exploration of space. We're explorers dedicated to making the future better for all humankind. Now, as the world's largest independent space organization, we are rallying public support for space exploration, making sure that there is real funding, especially for NASA science. And we've had some success during this challenging year. But along with advocacy, we have our STEP initiative and our Neo Shoemaker grants. So please support us. We want to finish 2025 strong and keep that momentum going into 2026. So check us out at planetary.org/planetaryfund today. Thank you.
I have so many questions if I want to follow this up, but let's pursue this a little more, because you make an argument in your book that looking back to the frontier, at least in the US as the example, the significantly negative consequences to the environment, but also to the native peoples who lived there first before the European settlers came through. But then you would say with space, oh, well, I mean, it's just space. There's just a bunch of ugly brown rocks. There's no life, particularly on these asteroids. Go for it, right? Go at it. But you make an argument in your book that there is a intrinsic value to these natural spaces, regardless if they have life. Expand on that first before we continue on. What are these intrinsic values that we need to consider from an ethical standpoint?
I don't know if I officially endorse the arguments that try to uncover intrinsic value in space environments. I don't know that they're wrong. Some of the criticism that's been lobbied against them in the literature, I don't think quite pans out. So that's an issue where I just discussed that for the sake of, enmeshing the book a bit more in what other philosophers have said. But
well, don't they have there's a scientific value, right?
So, yeah, I mean, I think the knowledge and understanding that can be derived from the exploration of pristine environments has intrinsic value. And that's something I think we need to sort of compute alongside the potential value of other activities in these environments. And of course, most of the space environment is completely unexplored. It's in its relatively pristine state. And that's the best situation in which to study it, because you know that there haven't been any human perturbations to affect the development of the environment. And so, everything that's there was there for natural reasons, as it were. And so when you have humans that get on the scene, be they explorers there, be they commercial miners or settlers, they're not going to be keeping track of the changes they make in ways that will be helpful to, later planetary scientists that come on the scene to try to figure out, all right, is this rock here because of some crater impact ejection, or is it because, somebody threw out some mining tailings? So the ambiguity can really creep up once you start disrupting these environments. That's not necessarily a permanent prohibition on, commercial activities in space. It's more of an argument that says, can we at least get the science done to the satisfaction of the scientific community before some of these other things come up? Even if there aren't, people there, even if there's nothing of scientific value there, how you do things affects the lives of the people that are going to be doing the work.
I found it just really interesting, again, that this so naturally came out of, once you establish science, is intrinsically valuable, and space science, having both of the, just, it's valuable to do it, then suddenly, and everything is of interest to us. Then by default, at least your kind of default mode that you engage with these, or what decisions should we make to preserve the scientific feasibility of exploration of these areas first? That should be the primary concern almost. I never quite seen it phrased that way. And I can see and probably hear people already arguing with this to say, well, that just means we'll never go anywhere, right? So if we make everything this pristine environment to understand first, and science budgets are low, it'll take thousands of years to explore all these areas. Therefore, if we really want to have space exploration, we should relax that constraint and just prioritize whatever works in order to get us out there faster and more people out there. And then there'll be more science as a consequence. So overall, the net will be positive. So, I mean, and this obviously touched on this very basic ethical question that you probably deal with in your 101 classes of philosophy and ethics, which is, how do motivations impact the ultimate outcome? So let's say space resources, commercial space, mining asteroids in the moon. We'll say, if there's greed involved and individuals will put up their own money and then somehow they enable more exploration, even if they ruin, let's say, to some of these areas to scientific exploration in the future, is that a price worth paying to get to this point? Like, I live on the West Coast. The natural exploitation that happened 100 years ago is a catastrophe. But at the same time, Seattle wouldn't exist here now to lead the environmental movement as it stands now. How do you phrase, or how does an individual, let's say, think about the ethical responsibility of why we go out into space, and what compromises, if any, do we have to make in order to get to the outcomes we want?
I'm taking what a lot of folks might describe as an extreme position that I'm trying to develop in the book. I'm really trying to build the case for space science as strongly as I can, and to, identify that there do seem to be some pretty significant values that speak up in its favor, and that, these other activities, maybe when we look at some of the thornier details involved, don't seem to hold up on some of their promises. ultimately the goal is to try to, increase the size, the share of the attention that space science gets in sort of stakeholder conversations and policy discussions and developments. Because one thing that's been kind of depressing to notice is that a lot of these new laws on the national level or these documents and conversations that are coming out tend to leave scientific concerns almost completely by the wayside. That it's just, let's enable this industry to start mining asteroids and, not be concerned about any downrange consequences to any other sector there. I think there's an important role to play in the first place, getting science a bigger seat at the table than it's got right now. It's a little disheartening to see what's happening in the case of Mars in terms of planetary protection and concessions being made to enable increased human activities, even though there's still a lot to do in terms of robotically investigating that environment, searching for, signs of possible past life or maybe even signatures of existing life on Mars. The scientific question about life on Mars is one that you could render permanently unanswerable if you engage in extensive human activities too soon. There might be some kinds of research that are still able to be conducted after humans get on the scene and exploit things or build their societies. There could be a lot additional science just because you've got, more investigators on the scene. But there are important questions that end up being unanswerable. And so I think it's an important thing to do to identify what are the questions we really want answers to that we don't think we can answer very well after commercial or settlement activities take place. And can we prioritize those? And, to the person that says, well, if we've got science budgets so low and that's going to make it take so long to get my Mars colony, I would say, well, why don't you try to lobby for more science funding right now? Because then we can get some of the stuff out of the way and open up that environment to other uses because we've learned what we need to for the time being. And of course, I can maybe envision some, geologists saying, well, no, I need to go back to that site for a long time. Different areas of science are going to require different lengths of time to study environments. They're going to petition for different moratoria on other activities. I'd love to see these conversations increase tremendously. Another thing to say here is that if you don't do good science before you go to space, how do you know that you can actually survive there? So the case of Mars is an interesting one. Mars is the third most explored body in the solar system, right? After the Earth and the Moon, it's the thing we know most about. But do we know enough to ensure the long-term sustainability of drilling into the subsurface and melting the ground ice for water? What's that going to do to the local geology of where your settlement is? Can that be conducted sustainably, effectively? I just don't think we have the overall understanding of Mars as a geological system to know for sure that we can support permanent self-sustaining settlements. Is it okay to go throw people into that situation without that knowledge? I'd really worry about that. So science can enable other activities, can sort of be the initial investigator that, lets us know when it's okay to establish a settlement, what's a good site, what asteroids are more likely to be ones that are promising for commercial exploitation. There was a paper that came out criticizing an older version of some of my arguments, and the person said, well, if we visit asteroids at the same rate as we do now, it might take 10 billion years to see all of the near-Earth asteroids, and commercial exploitation is going to get us there so much faster. And if you've got a big business that's harvesting a lot of material, I wonder who's purchasing that. What can you even economically create a company that makes profit to do this? That's a big question mark. But what guarantee is there that there would be scientific access to these places? It's not something that's just magically going to happen unless people fight for it along the lines of these regulatory discussions. So even if it's politically unfeasible to have some sort of moratorium on commercial exploitation, it's not as though the commercial exploiters are, out of the goodness of their heart, with no advance notice, just simply going to deliver sample materials to scientists. That's something that's going to have to be built into the system that commercial operators would have to be compelled to do if there are going to be substantive benefits to the scientific community from these commercial activities. And so I think there's that avenue to have some productive conversations about policies that get designed that are compromise policies, but, still don't preclude any interesting scientific investigations from ever taking place on an asteroid or on Mars.
Yeah, that's why I think your book is so timely. I've been stewing this in my head for the last couple of years. I feel like there's been this quiet shift in emphasis in space exploration, at least in the United States, towards that natural resource exploitation commercial motivation. We've moved away less so from even the grand exploration romantic frontierism to, hey, we can make money here. And is that really why we have a national space program, is to create mining colonies, like work colonies on the moon? But it's happened so quietly, and it's definitely rides with these broad social interests and kind of cultural moments that we're in, of the kind of savior complex of billionaires, I think, or people who can cut through red tape, or maybe the collapse of support of public institutions. But regardless, I feel like we need to decide what we want. And this is what I think really resonated with me out of your book, is that building this into our policies, even if we do go and support primary kind of exploitation, commercialization policy, you can still decide how you want to do that. Mm-hmm. And I think that's what's so important for us to consider, like in these kind of democracies where we have the ability to guide these going forward, that having some ethical consideration of how we pursue what we want to do, even if it's imperfect, seems to be a high priority for us to consider.
And I think the reason why folks have been able to successfully not be aware of this for so long, it has to do with when they think about space and its resources, they just tend to think of everything that's there in total. And, those numbers are just absolutely staggering. I want to say John Lewis, one of the sort of first folks to start discovering near-Earth asteroids, right? He'll talk about how the resource base in the solar system is enough to support, quadrillions of human lives. Maybe that was just the figure for the near-Earth asteroids. I forget if that was the total system resources or just the NEA resources. But when this is what you're sort of taught, and this is how space is advocated to you, of course you think that, space is practically infinite. And why should we ever have to care about limits to growth? Why should we be concerned about, how we distribute these resources? Because there's more than enough for everyone. And I think the sort of antidote to that is recognizing that if you care about doing this anytime over the next 50 years, you're not going to be able to access limitless resources, right? The stuff you're going to get is only going to come in a slow, staggered trickle. I mean, just think about the ice in the permanently shadowed regions in the north and south poles of the moon. That is a very limited, non-renewable, or at least non-renewable over, scales of millions of years resource. So once you use it up, it's gone. And there's not a whole lot there in the first place. We're talking about just a handful of cubic kilometers of water ice based on the estimates we've seen so far. And there's a lot of error in those estimates, so maybe what's there is a lot less than we think right now. Maybe it's a lot more. Nevertheless, it's not this inexhaustible pool. And so if we only have that much to work with for the next few decades, how we use it, what we do with it really matters, because you hear the bootstrapping argument all the time that, we just need to get out, get our first mining operation, and that'll make resources that we can then use to go out further, and so on and so forth. Well, that's not an inevitable future. You actually have to make sure that you're making decisions in ways that enable the bootstrapping, that you're being careful with how you use the resources that you're exploiting to make sure that you're producing equipment that can go further afield. So, I really worry that if we're stupid with lunar resources and near-Earth asteroid resources, we just won't ever develop the ability to send humans any further than that, to establish, main belt asteroid mining operations. So, even if you think that commercial exploitation is the main thing to be doing, you still have to think very carefully about how to implement it in the first place. And then, of course, we have to ask who benefits from it, right? Is this profit that solely accrues to the companies that are running these operations? That doesn't sound to me like a situation where humanity has gotten a whole lot of benefit from this. It's just a few folks. Even if we're doing this for the exploitation of the resources because we think that those will somehow benefit the world, We need to think about, is there a way where that benefit could actually be felt by people other than the already wealthy folks who are launching the rockets? We can disagree about what to do once we're up there, but even if we decide this is what we're doing, we need to think all kinds of ways about how to implement and best achieve that activity. And so I think this points to a real important value for ethics, for philosophy, which is ethics doesn't end once you launch your mission, right? Ethics is not a sort of checkbox that you just tick off and say, okay, now you're good to go do whatever. It has to do with providing active consideration to your activities, asking, what have I assumed that might not be true? What are the impacts of these decisions I'm making now? It's sort of like bioethics doesn't end once you build the hospital, right? The need for ethical decision-making doesn't end once the hospital is up and running. There are all kinds of situations that you run into, once you start practicing medicine that call for ethical consideration. In space exploration, it's the same thing. Once we're up in space, we're going to be encountering all kinds of new situations that are going to require ethical analysis.
It anticipates a question I was going to bring up, which was, how contingent are these ethics based on who's paying for it or who's doing it? Some people may be thinking, well, public investment in space, sure, I can understand they should have a thing for investment in science and priorities. But if you're Jeff Bezos, it doesn't matter because it's your own money. But what you seem to be saying here is that because of the larger long-term consequences to anybody, based on the usage of limited resources or altering of the pristine scientific environment of these places, this is a broadly applicable set of ethics, regardless of who's doing it or who's paying for it.
Exactly. I mean, in practical terms, we're dealing with some pretty finite and limited resources. To treat this as though it's something where scarcity is not a concern on anyone's mind, and so people can just be free to do whatever they want, just really mistakes the physical facts of the situation that we're in. And that does mean we have to ask these difficult questions about conflicts, right? About competing interests. And of course, that's one thing that ethicists really specialize in is, looking at situations where there are competing interests and asking questions about, okay, who's proposing to do what with this? Who's providing an opportunity for more overall benefit to humanity or something? I mean, these are questions I'm currently teaching an ethics of space exploration class. And this is an issue that keeps coming up, that, we have these competing camps and, what are the reasons that people on different sides are offering for more commercial activity or for more restrained commercial activity? And these are difficult questions. What I would resist is people just presuming that there's no conversation to be had here at all, because there's a very important one. And if we don't have it, we could well end up with a human future in space that doesn't do the things that most of us were hoping it would have done.
I want to pivot here slightly to touch on the human aspect, and in two ways. We alluded to this earlier on, and some of our listeners may be reacting to that. So I want to make sure we talk about this a little bit more. The role of long-term benefit, offsite backup for humanity, space settlement, and for the success of human life, for the flourishing of human life, and for the long-term survival of the species. You acknowledge in your book, obviously, the sun is eventually going to turn to red giant, and Earth is screwed. If we want to live, humans want to live multi-billion years.
He's not quoting directly there.
Yeah, I'm summarizing. However, what was interesting to me is that within the near term, just like you talked about the conditions and qualities of life on likely near-term settlements as a way of basically deprioritizing their moral obligation to pursue those compared to science. What are some of the problems with space settlement now as a moral obligation for the survival of the species? Why shouldn't that be the top priority of spaceflight?
So I agree that the obligation that underlies this is a pretty strong and compelling obligation, that, we have a duty to survive as a species. As a philosopher, I'm going to have all kinds of questions about space aside. What does that mean? What does it entail? But I do agree that over the long term, which to me means, at least a couple centuries down the line, that it's a necessary outlet for satisfying that obligation, right? So just to be clear, as you've mentioned already, but just to say, from the horse's mouth here, yes, I do think over the long term, we have an obligation to seek out, self-sustaining settlements in space. The problem with this, thinking about it as an activity to start right now, relates to what the people that would live in those settlements would have to endure. And I think this push to do this as soon as possible with, as few resources as possible, this bare bones depend completely on in situ resource utilization right from the start approach, is either going to just kill a lot of people very quickly or force them to live very, very difficult, toilsome lives. So I think insufficient thought is being given to how these societies in space will be arranged, situated, governed, what kind of liberties folks might have. And because we're thinking about human settlements where we want them to be self-sustaining and growing, the initial folks that go up there are going to have to start, making babies. And so even if we can find some, acceptable contract that the initial settlers can sign that says I understand what I'm signing up for, I consent to it, that next generation, the first generation born on Mars, presuming that's a physiological possibility, which we don't know yet, right? They never had a choice, and they're probably biologically adapted to Mars too much so to ever come to Earth. So they're stuck there. So is it permissible to rear the next generation of people in a situation where you're probably existing permanently in a small, confined habitat, where to go outside, you're going to have to don a pressure suit, where if you open the wrong door at the wrong time, you depressurize the entire habitat and kill everyone? I mean, think about the kinds of surveillance and social systems that are going to need to be in place to ensure that the colony survives on a second-to-second basis. Some colleagues of mine will say that this is a situation ripe for tyranny, ripe for, dictatorial, authoritarian control, of the kind that you might have seen in Total Recall, where they sort of vent the atmosphere to one of the habitats. To say that, let's just do this as soon as we can and it'll be this experiment, I think is a very reckless idea, because we know about some very likely problems. And what we need to figure out before we really go is, how can we give these people the best start to avoid these problems? I worry even more when it's a private organization doing this, because, if you're setting up your moon colony or your Mars colony for the point of, making a profit, then human well-being is not going to be a priority of the way decisions are made. When people say, well, if it's their money, they can do what they want, I worry more in those situations than if it's a place run by a terrestrial government that's still accountable to its citizens.
This is a small part of your whole book here, but I just found this fascinating because, again, it touches on thoughts that I've had that I haven't formalized personally yet. But it does seem to me that in terms of these space settlements on a place where the concept of individual liberty is almost anathema to what the conditions on the ground will be. Mm-hmm. And from what you were just saying, like even with family planning, let's say, or child, like family size, in the frontier on Earth, you had air to breathe and you could go somewhere and live off the land because there's animals and you could plant vegetables. On Mars, you have to build an expensive and highly complex additional habitat to grow another family into. Or the same thing, one person could easily kill everybody on purpose or by accident. And the consequences to what type of society you will have there don't seem to be very positive from all the reasons you were just saying. I see a pathway, but how does science as a priority first help and ultimately enable something that is necessary for the long-term flourishing of humanity, even if now is not the right time? Like, how do we balance those two things? Because it has to be done eventually.
Yeah, I mean, so there's this sort of precursor science where you're investigating the environment to ensure that it's got, the right things to support your human society as it grows in the future. And then there's this sort of more psychological, sociological stuff you've got to do in terms of, can humans successfully exist in these places? What modes of government are going to be most successful here? This is a really tricky question. In part because if you really want to do a good test, you're going to have to throw people in that situation. Good luck running that by an institutional review board, right? I mean, there's going to be all kinds of reasons to worry about, running that study in the first place. One of the things that folks who are thinking about this have been reaching out to smaller communities. I attended a conference in London, would have been a year and a half ago, that was attended by a few academics like myself, but also some people from planned communities, eco-villages throughout Europe, talking about their experiences living in these, smaller societies, albeit ones where they still have the ability to leave, to go out into the sort of general public and lead a life with a much larger society if they choose. What can these things teach us about how people get on with one another, how leaders are selected, how decisions that affect all of the villagers are made? Those are areas that we need to look to. But it really is just, kind of ramping up, especially sociological research on this issue about, how can you successfully govern isolated small environments? And, if you're coming at this from a Western angle, you care about individual liberties. So how can these folks be minimally surveilled? And so Charles Cockle is an astrobiologist that also is the sort of spearhead of these discussions about liberty in the space environment. He'll talk a lot about how there are some engineering principles you can employ to do this, that as far as environmental monitoring, can you make sure that, your sensors that are tracking the movement of seals don't also listen in on conversations, right? So can you just have a dedicated sensor for this one thing that can't be reappropriated as a way to spy on people's conversations? Can you design spacesuits to be a bit more modular so people have a greater access to the ability to go take a walk outside the habitat? Can you multiply your food and oxygen production systems so that, if one machine doesn't go down, people can still survive and people aren't fully under the control of the folks that operate that one machine? So there are a lot of things to be working on, and I'd hate for the only experiment we really do to be the first time that we put people on Mars. I think there's a lot we can work on and try to figure out with less controversial experiments here, and including also on the ISS. There's a lot to learn.
It's one of those things, though, I think it's important. This is where the value of sitting and thinking through the ethical consequences of what we're doing now is going to be highly sensitive to these initial conditions wherever we end up going. And so I think that's a rich area for listeners to consider about how we proceed. What are these long-term consequences? Ultimately it comes down to, again, I assume is another very basic philosophical quandary, which is what are our obligations to the future? What do we sacrifice for the untold number of people who will live ahead of us? I know there's some balance to strike there, but it's also important that we do some of this work so that we set things up to succeed in these long-term ways beyond even the kind of timeline that we're looking at as individuals or even our direct ancestors.
Yeah, exactly. Because the attitude that says, I want to do this as soon as possible, as soon as the most basic technology to enable it arises, that's a prescription for a really awful situation. That's the beginning of every really awful science fiction TV series, when you try to do things in the quickest way. And, when you look at discussions about, the genetic variation you would need to have for a successful space settlement, you can find folks that winnow the number of folks down to like 40s and 50s. Much more common, you'll hear numbers in the hundreds. But some people think that, if you engage in the right selection process and people pair off in the right way, you could have healthy genetic variety with a population as low as 50. I really worry about that because reproducing is the kind of thing you should only ever do if it's what you want to do with the person you want to do it with. And if you're in a situation where the governor says, no, you have to mate with this person on this occasion and have a baby with them, whether you want to or not, I think that would be an unacceptable situation to put someone in. And we have to remember that it's not as though this is some already existing society with its own traditions that we have some obligation to respect out of cultural tolerance. This is a society we're creating. And if there are going to be hardships that people living in it experience, they will be because we made decisions that led to those hardships. So I think our obligation here is very much centered around not just doing the bare minimum, but trying to provide the best life we can for the people that are going to be living into space, because that's the only way we're really going to make progress as a species. If you think space is supposed to be something that's going to really help us out, why are you saying it's okay to take this huge step backwards when it comes to treatment of individuals just to have a space settlement? Because if it's a really awful place to live, it's probably going to fail in the first place, and now we don't have the backup planet anymore.
Let's come back to where we started and ground ourselves now kind of in the here and now. We've talked about, again, the obligations for exploration broadly. You've made your arguments for science as the top priority for why we should go into space and how to consider and think about decisions we're making now. For people listening, can we bring it down to the individual? To summarize kind of these broad arguments you're making, what are our individual obligations to support space exploration?
Well, one way you can help is by donating to the Planetary Society.
I did not
join up.
Do that.
It's true, but it seemed like a really good thing to mention there. But yeah, no. So participating in advocacy organizations that are dedicated to advancing space science causes is one way, and it's helpful because a lot of people might want to see something happen but don't like to call their congressperson. One way to do that is to join up in different kinds of organizations that have these purposes. But when the occasion arises, when the topic comes up, to have some clearly outlined ideas about, oh, you're talking about space mining, but did you know this and that, there's this cost to it. Or you're talking about space settlement, but did you know there might be a reason to investigate Mars further before we get humans right there? At an individual level, I think it's just coming to appreciate more and more about how science operates. What the process is from, at least in terms of NASA missions, from mission proposal to launch. What are all the different things that have to go right to ensure that happens? Where does someone need to jump in to offer different kinds of political support? What's the role of public opinion? And it does seem like there's some evidence that suggests that space policy is kind of responsive to public opinion. So making sure one participates in relevant public opinion polls to demonstrate their interest in space. A lot of things.
The takeaway for me is that everyone has a moral obligation to join the Planetary Society. So I'll do. Thank you so
when
much.
I joined, it was out of a sense of obligation that this seemed like a group I felt I needed to support given my position. So,
that's there you go, as a perfect example of that. And I had the same. I was a member before I worked here for many of the same reasons. So I want to thank you again for taking the time to join us today. A fascinating conversation.
Thank you so much.
We've reached the end of this month's episode of the Space Policy Edition of Planetary Radio. But we will be back next month with more discussions on the politics and philosophies and ideas that power space science and exploration. Help others, in the meantime, learn more about space policy and the Planetary Society by leaving a review and rating this show on platforms like Apple Podcasts or Spotify or wherever you listen to this show. Your input and interactions really help us be discovered by other curious minds, and that will help them find their place in space through Planetary Radio. You can also send us, including me, your thoughts and questions at planetaryradio@planetary.org. Or if you're a Planetary Society member, and I hope you are, leave me a comment in the Planetary Radio space in our online member community. Mark Hilverda and Ray Paoletta are our associate producers of the show. Andrew Lucas is our audio editor. Me, Casey Dreier, and Merk Boyan, my colleague, composed and performed our Space Policy Edition theme. The Space Policy Edition is a production of the Planetary Society, an independent, nonprofit space outreach organization based in Pasadena, California. We are membership-based, and anybody, even you, can become a member. They start at just $4 a month. That's nothing these days. Find out more at planetary.org/join. Until next month, ad astra.